Hey everybody, hope you're doing all right out there. This is the video to go along with the lesson for Monday, the gray day. I think it's November 9th. And this was going to be a part of a homework assignment, but I've just made it into a practice basically. It's 3 of the book problems, 10, 11, and 16 from section 5.2, which is the section on just turning it up. So we're going beyond corresponding parts. And I figured I would do one of these 3 proofs on the video and then let you guys try the other 2 on your own. So I think I'm going to do 11 and leave 10 and 16 for you to try. So if you would benefit from watching the video for number 11, feel free to, or you could just try it on your own and then check the partial solutions and see if you got the right idea. But for those that feel like they want a little bit more support, that's why this video is available. So hopefully this is helpful for those. If you don't need to watch it, feel free to just try the 3 problems on your own and you can submit to Canvas. So I'm going to create my 2 columns for my proof. I'll write in the givens. Of course, you don't have to do that if you want to just use an arrow. So we're given that G is the center of a circle, and we're also given that GE bisects something, and in this case it bisects an angle. So that's an angle bisector, which creates 2 congruent angles. So I'm going to go in and mark those angles. So GE bisects AGM. Okay, so I'll do GE cuts in half this red angle. So that means that angles 1 and 2 will be congruent. Okay. Also realize that we have radii of a circle, so we'll be able to say AG and GM are congruent. And then we'll also be able to say that EG is congruent to itself, so I'll mark that by doing that. And then I'm seeing 2 congruent triangles, one on the top, one on the bottom. So hopefully you're seeing that too. So I'll go to the next step, which would be from that given, I'm going to say that angle 1 is congruent to angle 2. And that's because bisect implies congruent angles. And then step 3, let's do the radii. So let's say to the jury that AG is congruent to MG. Those are the 2 radius lengths. And that's because a circle implies radii congruent. Okay, so if you're keeping track for congruent triangles, we have an angle, we have a side, and then let's go find the other side, which in this case is the low-hanging fruit, the easy one of EG is congruent to EG, and that's by reflexive. Okay, and now we have a side, another side I should say, but it's not in that order, it's in the order of side, angle, side. So we now have congruent triangles, which will help us get where we need to go to prove in the end. Let's even take a minute to look at what we're trying to prove. I didn't even think of that. So AER, so I'm going to call that angle 3 right there, is congruent to MER, angle 4 right there. So these are angles that are actually outside of the triangles we're looking at. However, they're closely related to this angle right in here, which I'm going to call angle 5, and this angle there, which I'm going to call angle 6. So if I'm able to get angles 5 and 6 congruent, I will be able to get angles 3 and 4 congruent, which is what we're trying to prove. Remember about supplements of congruent angles. All right, so let me show enough that you can see where I'm going. So this 5th step, I'm now ready to say that triangle AGE is congruent to triangle MGE. Notice the corresponding parts there. And then the reason for that is because of side, angle, side. Awesome, we have congruent triangles. And now any corresponding parts that we want to call congruent, we can call congruent. So I'm grabbing 5 and 6. So angle 5 can now be stated as congruent to angle 6. And that's because of congruent triangles imply corresponding parts congruent. Okay, hopefully that statement, that justification is becoming more familiar to you. All right, we got 6 steps and we have angles 5 and 6 congruent. And now it's that kind of annoying process where you have to state we have supplements because we have straight angles, and then we must have congruent angles because they're subs of congruent angles. So here are those 2 steps. I'll try to fit my diagram in there. So we need a step that says that angle 3 is sub to angle 5, and that angle 4 is sub to angle 6 in my diagram. And this is because we're looking at a straight angle on the diagram, and a straight angle implies subs. Oops, let me finish that off. So a straight angle implies a pair of supplementary angles. So 3 and 5 are sup, 4 and 6 are sup. And then finally, we can now say, because 3 and 4 are subs to 5 and 6, they're subs of congruent angles, therefore 3 and 4 are congruent, and we're done. So angle 3 congruent to angle 4 because, oops, they are subs of congruent angles, and that implies that they're congruent to each other. Okay, so it's an 8-step proof, definitely beyond congruent triangles. Look at the steps. We have 1, 2, 3 steps beyond congruent triangles. So that's what we mean when we say in section 5.2 that we're turning it up. Okay, hopefully that was helpful. Please now finish 10 and 16 using the hints, partial solutions as hints as you need to, and then submit to Canvas, and that's all you need to do for today, the gray day. All right, have a good day. I will see you in the next block class.